Hello friends, welcome to my channel. Today we'll discuss about the loop optimization techniques. Okay, so loop optimization techniques, we can also say peephole optimization techniques. So you can see the definition. Loop optimization technique is a process of increasing the execution speed and reducing the overheads associated with the loops. Okay, so loop optimization is a process of increasing the speed and reducing the overheads. Guys, important. So the purpose of this loop optimization is it is to increase the execution speed. Okay, so by reducing the overheads. So let us see what are the techniques belongs to the loop optimization techniques. You can see on the screen. The first one is frequency reduction. Say first one is the frequency reduction. Second one is the loop unrolling. Third one is the loop fusion or loop terminating. Fourth one is the strength reduction. Okay, so these are called as loop optimization techniques. So here the first one is frequency reduction. Second one is the loop unrolling. So first one is the frequency reduction. Second one is the loop unrolling. Third one is the loop fusion or loop terminating. Fourth one is the strengthening reduction. So let us see one by one now. So first one is the frequency reduction. This is also called as code motion. Okay, so this is also, you can say frequency reduction is also called as code motion. In frequency reduction, the amount of code loop is decreased. So the amount of code loop is decreased. So in this we are going to decrease the code which belongs to the loop. Okay, so one of the important point. So this is all about the loop. So in this we talk about the loop code is terminated or decreased. So we are going to say this is decreased. So you can see the example on the screen. If you see here, before optimization what happened, while I is less than, or you can see here, while I less than or equal 100, a is equal sin x by cos x plus I plus plus. So you can see this program is, we can say, before optimization. Suppose what I can reduce from this, while I less than or equal 100, a is equal sin x by cos x, I can write this is as a is equal to tan x. So you can see after optimization what will be happened here. You can see t is equal to sin x by cos x. So while I is less than or equal 100, a is equal to t plus I plus plus. So if you see before optimization what happened and after optimization what happened in this program. So here before optimization a is equal to sin x by cos x. So every time you need to find out the sin x by cos x value here. But if I go for this one, what is going to be happen? Just I am going to perform t is equal to sin x by cos x one time. So by the way, I can substitute this value. So in the above program, every time we are calculating the value of this sin x by cos x. If you see here, one time only we calculate, so we substitute here. This is called as what we say after optimization. So this is called as, if you see in this program, so every time we are calculate a is equal to sin x by cos x. So it will increase the cost of the loop. So on the other side what I am going to do, so I am going to do above starting only, I am going to perform t is equal to sin x by cos x. So now you can see next one is the loop unrolling. Very important point, loop unrolling. So in this technique the number of jumps and text can be optimized by writing the code without changing the meaning of your code. Guys, important point, loop unrolling. So in this number of jumps and text can be optimized. So we are going to reduce the number of loops in loop unrolling. Very, very important point. So you can see here in this program what is going to be happened. So in the loop unrolling, so here in the loop unrolling, so in this technique, the number of jumps and text can be optimized by writing the code without changing the meaning of a code. Now you can see here in this int I, this is int I is equal to 1. Before optimizing, while I less than or equal to 100, a of I is equal to b of I, a plus plus. So this is a program. Let us see how this will be optimized. So now this is called as what we say loop unrolling. So you can see here int I is equal to 1 while I less than or equal to 100, a of I is equal to b of I. So next I plus plus, then a of I is equal to b of I. So if you see here, this program will take 100 number of steps, because 0 I is, let us say 1 less than or equal to 100. So this program will take 100 number of times to execute, because 1 less than or equal to 100, I plus plus 2, 3, 4. So this is about the before optimization. But if you see after optimization, what is going to be happened here? So what I am going to do, I am going to perform this is 2 times I plus plus, I plus plus. So here I plus plus is 1, this is 2. So overall this program will execute only 50 number of times, because of we are going to increase the I 2 times. So this is called what we say after optimization. So let us go for loop fusion. Its techniques combines the bodies of 2 loops. So you can see here this technique combines, very, very important point, combines the body of 2 loops whenever same index or variable number of iterations shared. Okay, so you see here the example for I is equal to 0, I less than or equal to 10, I plus plus, printf Python, I is equal to 0, I less than or equal to 10, I plus plus program. So I am going to print Python program by 11 times. Now this is called as what we say here, this is a loop fusion or loop jamming. So next one is what we have, strengthening the reduction. Replacement of higher strength operator by lower strength operator is called as strengthening the reduction. You can see instead of writing this T1 is equal to A into 2, I can write T1 is equal to A by 2. So here this is A into 2. So this is here A into 2 means it will give the answer as 2A. But if you see here, we are going to reduce as, so strengthening the reduction in this replacement of higher operator by lower operator. So so important point, A into 2, this is equal to 2A. I can write as A plus plus, A plus A. So the value of this one is same. Okay, but if you see A by 2, I can also write as A right shift 1. Okay, so but if you replace this A into 2 as A plus plus, star is costlier than plus, division is costlier than right shift operator. So this is all about the loop jamming. Okay, so thank you for watching this video. Please subscribe my channel.